Using electrical conductors as a means of support for fixtures is not legal. Article 410.28 F prohibits using electrical conductors as a means of support for fixtures unless specifically approved. Using a coaxial cable to feed the fixture is probably not legal either. Article 411 does not address using coaxial cables for lighting. However, since the fixture is not listed, it is possible that the manufacturer has approved the use of coaxial cable. Having a fixture that is not listed or homemade is not legal. Article 410.4 requires fixtures to be listed for their intended use. Whether it is a moot point because it is low voltage is irrelevant. Low voltage does not make it a moot point. While low voltage fixtures are exempt from some national electrical code requirements, they must still be installed safely. It is not legal to use the wires as a means of support, use a coaxial cable to feed the fixture, or have a fixture that is not listed. The fact that the fixture is low voltage does not make it exempt from these requirements. Let's delve deeper into the specific code sections and why these practices are deemed unsafe. Article 410.28 F concerning means of support is very clear. Electrical conductors are not designed to bear the weight of lighting fixtures. They are primarily intended for conducting electricity, not for structural support. Using them as such creates a significant safety hazard. The conductors can become stressed, leading to insulation damage, short circuits, and even fire. Furthermore, the set screw connection, while seemingly convenient, is not a reliable method for securing a heavy fixture to thin gauge wires. Vibration, temperature changes, and even the slightest movement can cause the connection to loosen over time, potentially leading to the fixture falling. The article specifies that fixtures must be supported by approved methods such as chains, hangers, stems, or other suitable hardware that is specifically designed for the purpose. These methods are engineered to safely bear the weight of the fixture and maintain a secure connection over an extended period. Now, regarding the use of coaxial cable, Article 411, which typically covers low-voltage lighting systems, does not explicitly address the use of coaxial cable for powering fixtures. Coaxial cable is primarily designed for transmitting radio frequency signals, not for carrying electrical power. While it may be possible to find coaxial cable that is rated for voltage and current levels suitable for low-voltage lighting, it is crucial to ensure that it meets all applicable safety standards. The cable must be properly insulated, and its ampacity must be adequate for the load it will be carrying. Furthermore, the connections must be made using approved methods and connectors. However, the absence of specific guidelines in Article 411 raises concerns about the suitability of coaxial cable for this application. Electrical codes are often very specific about the types of wiring methods that are permitted for different applications, and the lack of mention of coaxial cable suggests that it is not a generally accepted practice. The fact that the fixture is not listed adds another layer of complexity to the situation. Article 410.4 requires all luminaires, lamp holders, and retrofit kits to be listed by a qualified testing laboratory. Listing signifies that the product has been tested and certified to meet certain safety standards. This includes requirements for electrical safety, fire resistance, and mechanical strength. Unlisted fixtures have not undergone this rigorous testing process, and their safety and reliability are therefore questionable. They may contain defects in materials or workmanship that could lead to electrical shock, fire, or other hazards. Even if the fixture appears to be well made, without proper listing, it is impossible to know for sure whether it meets all applicable safety requirements. The fact that the fixture operates at low voltage does not exempt it from these requirements. While low voltage systems are generally considered to be safer than high voltage systems, they still pose certain risks. Low voltage wiring can still overheat if it is not properly sized or installed, and low voltage fixtures can still cause electric shock if they are not properly grounded. The National Electrical Code provides specific requirements for low voltage lighting systems, including requirements for wiring methods, overcurrent protection, and grounding. These requirements are designed to minimize the risks associated with low voltage electricity. Therefore, The fact that the fixture is low voltage does not negate the need for it to be listed and installed in accordance with all applicable code requirements. In conclusion, the scenario described violates several key provisions of the National Electrical Code. Using electrical conductors as a means of support, using coaxial cable to feed the fixture, and having a fixture that is not listed are all prohibited practices. The fact that the fixture is low voltage does not make these violations any less serious. To ensure the safety of yourself and others, it is essential to follow all applicable code requirements when installing electrical fixtures. If you are unsure about any aspect of the installation, it is always best to consult with a qualified electrician. This ensures that the installation is performed safely and in compliance with all applicable regulations. Remember, electrical safety is paramount, and cutting corners can have serious consequences. Always prioritize safety and follow the code when working with electricity. The use of 24 American wire gauge conductors to support a heavy fixture presents several critical issues. Firstly, the gauge of the wire is far too small to provide adequate mechanical support. 24 American wire gauge wire is typically used for low current signal or data transmission, not for bearing significant weight. The risk of the wire snapping or the set screw connection failing under the weight of the fixture is substantial, creating a potential falling hazard. Secondly, even if the wire was strong enough to support the initial weight, the continuous stress and strain on the conductors could lead to fatigue and eventual failure over time. This is especially true if the fixture is subject to vibration or movement. The code prohibits using any part of the electrical wiring system for non-electrical support purposes unless specifically designed and approved for that purpose. In this case, the 24 American wire gauge conductors are clearly not designed or approved to support the weight of the fixture. The appropriate method of support would involve using a listed and labeled fixture hanger, chain, or other mechanical means designed to bear the weight of the fixture independently of the electrical conductors. These support mechanisms should be securely fastened to the building structure and capable of supporting at least 5 times the weight of the fixture, as required by the code. As for the use of coaxial cable to supply power to the fixture, this is generally not permitted unless the cable is specifically listed and labeled for that purpose. Coaxial cable is designed to transmit high-frequency signals with minimal loss and interference. It typically consists of a central conductor surrounded by an insulating layer, a metallic shield, and an outer jacket. While some coaxial cables may be rated for low-voltage applications, they are not typically used for power distribution. The primary reason for this is that coaxial cables are not designed to handle the same level of current as standard power wiring. The central conductor is often too small to safely carry the required current, and the insulating layer may not be rated for the voltage and temperature conditions. Furthermore, coaxial cables typically do not have a separate grounding conductor, which is essential for electrical safety. Using coaxial cable for power distribution could create a fire hazard and increase the risk of electric shock. If a specific coaxial cable is intended and listed for power distribution, then all the connections and installation methods must be according to its listing. The fact that the fixture is handmade and not listed by a recognized testing laboratory is a significant safety concern. Listed fixtures have been subjected to rigorous testing to ensure that they meet all applicable safety standards. This testing includes evaluating the fixture's electrical insulation, wiring methods, temperature rise, and mechanical strength. Unlisted fixtures have not undergone this testing and may not meet these minimum safety requirements. They may have design flaws, substandard materials, or poor workmanship that could lead to electrical shock, fire, or other hazards. The National Electrical Code requires all electrical equipment to be listed unless it is custom-made and specifically approved by the authority having jurisdiction. In most cases, it is very difficult to get approval for unlisted electrical equipment, especially if it is intended for general use. The low-voltage aspect of the fixture does not negate the need for listing and proper installation. While low-voltage systems are generally considered safer than high-voltage systems, they still pose certain risks. Low-voltage wiring can still overheat if it is not properly sized or protected, and low-voltage fixtures can still cause electric shock if they are not properly grounded. The National Electrical Code contains specific requirements for low-voltage lighting systems, including requirements for wiring methods, overcurrent protection, and grounding. These requirements are designed to minimize the risks associated with low-voltage electricity. The use of set screw connections on small-gauge wires is another area of concern. Set screw connections are generally not recommended for connecting small-gauge wires, especially when the connection is subject to mechanical stress or vibration. The set screw can damage the wire strands, reducing its current carrying capacity and weakening the connection. Over time, the connection can loosen, leading to arcing and overheating. A more reliable connection method would be to use crimp connectors or terminal blocks that are specifically designed for small-gauge wires. These connectors provide a secure, reliable connection that is less likely to loosen over time. In summary, the described installation practices violate several key provisions of the National Electrical Code and create a significant safety hazard. It is essential to follow all applicable code requirements when installing electrical fixtures to ensure the safety of yourself and others. If you have any questions or concerns about electrical safety, consult with a qualified electrician.